So I go sum of the scan area that we have for the points that we've identified here that have some sort of correspondences. And then we divide it by the sum of all of the areas. We go and we just copy it here. The sum of the area on the night scan. And if you see it, this whole basically object has been covered about 67%, right? That's what that means. 0.67 means that there's a fraction there. And I did it as a fraction just so that we can have more flexibility between the surface min and don't have that mistake again. That the surface min, we basically do it, or the surface min of local, which we're going to change its name, is for the percentage, and this one is going to be for a fraction. So we do the same thing. We basically say, okay, coverage fraction is larger than, you know, surface min. Our object is 1, else our object is is 0, and we basically do that for that particular object, right? And if in our object, in our function, the object is 0, that means that this object is not considered by means of what we've gotten here. That's what that basically suggests. So here I had it by means of a fraction, right? So we basically do that there. I typically like to do it earlier on because we're not going to use so much the X underline scan anymore. Overall, we're going to use the object-based ones, or the ones that we find here in this final set that we have. So we have the coverage fraction, we have the object, basically remove that and place that a bit later there. And you can play around with this however way you want. You can remove it, you can do whatever. There's no, you know, and then of course the rest of the aspects that you need to take under consideration, like the scan points covered, put all of them there as well. But then here, there are two surface mins. First of all, we can't use the same unless we multiply this by 100, because this is a fraction, the other one is basically a percentage, or we can just remove the 100 here. So this is one thing. So if you just use this program, it's not correct. However, I thought to myself, okay, why do we even need to use the exact same? You know, in a surface wise, you might have much more surface with respect to that, and then object wise, we might reduce that, right? So that's what I'm going to be doing. What I'm going to be doing is to finding out what, in terms of globally, we require there. So we can introduce two thresholds. One is surf, basically global, that I put here, or you can put object threshold or object surface threshold. It doesn't really matter. I just put it as surface min global and surface min local. So, and where we introduce it is here, and of course we talk about the comments there as well to make it nicer. So surface min of, let's say, local, that would be the first one. And the second is surface min of global, or object min, object surface, whatever you want to do, as long as there's consistency. Go and copy that on the top first one. And what is interesting is that surface min local is percentage, meaning is between 0 and 100. Surface min global is from 0 and 1. And this is only because of the fact that we introduce 100 in that percentage there. Okay, and points assigned. Anything else that you think, you know, you want to see how it happens, you can actually introduce it there too. So covered. Basically the rest. Percentage of coverage as a J function, meaning that it's basically a column vector. And then again, we have to initialize this. If we do that, like the same as the other ones, zeros of PO and 1. There we go. And then we basically put that there as well. Let's say at the end here. So we can get the percentage of coverage for every surface that we've had. You can get the area, you can get the STL, everything that you think you would be able to perform that there. And now let's go and basically see what we can get from this. So let's take a look at the final results of the object recognition. So if you take a look at this, we have our X underline scan. This is basically the same as what we had. You probably have the transformation, all of these aspects together with it. Okay. And again, I'm just showing that we just do the transformation there. Just enter this. Essentially, we go. And this by itself is going to show us the things that we want. But if we want to create the view, we just have to add a view free here to make it into 3D and then axis equal. And you're going to see what the difference is going to be like. Okay, just go object, then save. And then up, we basically go and copy this whole nice, neat new method that we've produced. Paste it here. Then really what I want to focus on is for just till the percentage of coverage. And then the X underline scan is there. You just put the 1 to 3. If you have X underline scan R, you can do it that way. And this is, again, the same foundation, or I actually did the sample mesh as a total. This is, I basically meshed the column and the foundation together just to show you what the results would be as a more global situation. Let's say we have 50% locally we identified, and globally 0. Let's say 7 here. I put quite significant, meaning if 70% of all of the surfaces are covered, this object as a whole would be covered. So I'm putting all of this objects, basically the column and the foundation, all as the same objects, essentially. Basically, we enter it to see what happens. Okay, so this is now what we get. What surfaces are there? And as you can see here, object is equal to 1. That means that this object is being considered as an object that is covered. And the reason why, because the coverage underlying fraction is actually 0.77. That means 77% of it is covered. But we only really needed 70% of it being covered, because this is larger than it would be covered. And the surfaces that weren't covered, of course, is the top one there. And then the bottom area there, this is obviously at least the bottom and the top is because the point cloud was not collected from the top and the bottom, but the sides there, for the most part, they were considered. And then the object is 1. And you can see for each and every one of these, how much of that surface was covered. So a lot of these, for particularly for the column around it, so about 90% of it was covered quite significantly. And then for the foundation, it was a bit less or a bit more. Basically, the top is the 0, meaning that the top of the top, there was absolutely nothing that was covered based on it. And then, or the bottom, however way you want to look at it. And then the rest, you have basically different ones.